we know vectors have magnitude and direction, but there's a special type of vector that we talk about as a unit vector, meaning that we don't really care about the direction much, but we do care about the magnitude, and that means that its length, or the magnitude of that vector, that unit vector, is 1. Okay, so we're going to just try and use that definition as we work through an example. So we have v, and we will see this representation of a vector in upcoming classes, but this is saying that we go 0.9 units to the right and down 1.2 units. So if I make a little sketch, which is part A, okay, I'm just going to say, okay, well, here's, 0.9 units, and then I go down, negative 1.2 units. Okay, so then my vector would go, over and down. So its terminal point would be right there if we imagined it starting at the origin. And here would be the vector v. Okay, and so now it says, is it a unit vector? Okay, well, I need its magnitude to be 1. Okay, how do I find that? How do I find its magnitude? Okay, also, when we talk about magnitude of a vector, that magnitude so we communicate the magnitude by enclosing the vector in double absolute value signs. Okay, that's just a bit of notation. Okay, but we want to find the magnitude. We want to know what its magnitude is. Okay, well, I don't know about you, but I'm zeroing in on this language of 0.9 units to the right, so that goes, this distance of 0.9 units, and then down 1.2 units. Okay, well, that's negative 1.2 only due to direction. Oh, and then I'm like, oh, okay, well, that's a triangle, right? Okay, so if I'm being asked to find the magnitude, which would be the hypotenuse, how can I find the hypotenuse? Okay, we've made it through trig doing lots of triangles. I imagine that you're probably just like, oh, do the Pythagorean theorem, right? Or if you didn't say that, I'm going to imagine that's what you said in case. Okay, so we would do magnitude of v squared, or length of the hypotenuse squared, would be equal to 0.9 squared plus, and then that's in parentheses, negative 1.2 quantity squared. Okay. And then I can do the calculation, but this should be 0.81, and this should be plus 1.44. And so then I get 2.25 for all of this. And this is for the magnitude squared. And then if I square root both sides, okay, so I introduce a square root, I would say the magnitude then is going to be 1.5. Okay, and here the hypotenuses that we've dealt with are always positive. Okay, so we found the magnitude. The question is this equal to 1? Okay, is this a vector? Is this a unit vector? And we're going to say no. Okay, this is not a unit vector. Okay, because its magnitude is not 1. Okay, but now how do we find a unit vector? Okay, we want its length to be 1. Okay, all I would say is that, well, if we know its magnitude is this, we need to shorten it, right? So all we're going to do is say, to find a unit vector, and here's the notation. We're going to say unit vector in the direction of v. Okay, all we have to do is take this and we're going to scale it. Okay, remember, so that we're going to multiply by cv. Okay, and the particular c that we're going to use is 1 over the magnitude. Okay, and mathematically, what this will do is it takes the length of the hypotenuse, okay? So v would have a certain length, right? If we looked at the magnitude of v, but if we take that length and divide by the length, like x over x, it's just 1, okay? So in general, we're just going to find a unit vector by multiplying our given vector by a constant, just 1 over the constant, or 1 over the magnitude of that vector. Okay, so then it says, is a unit vector? No. If not, find it in the same direction. Okay, so we'll see the vector representation in this component form later on, but we would just have to take and divide the vector, both components technically, by this magnitude. We'll worry about that later on, okay? And then if I wanted to find a unit vector in the opposite direction, how do I make sure that it's in the opposite direction? Okay, so I'm going to just say u of v, and then to communicate the opposite direction, I would just do minus, right? I change the sign in front and then will change the direction. I would just say, okay, well, do a negative of the unit vector that we found, okay? And that will change the direction. So opposite direction, and then this would be regular, or same direction, okay? And so there we go, okay? And we just said, again, to summarize here, that if we want to find a unit vector in the direction of a given vector, okay, just take the vector and multiply that by 1 over the length of the vector, okay? And the length of the vector, if you're wondering how to find that, again, it really is just the Pythagorean theorem, okay? Because you're treating, how far you go right as one leg, and then how far you go up or down as another leg, and then you're finding the length of the hypotenuse. Okay, so there we go. We've learned a little bit more about vectors and this concept of a unit vector. Okay, just meaning it has unit length, and to find that unit vector, we just take our given vector, multiply by 1 over the magnitude, which we can find the magnitude by using the Pythagorean theorem.